Okay, so hello everyone. The question which we will be solving today is count days without meeting. Okay, it is today's LeetCode POTD, and as you can see, the question is 3169 and it is marked as a medium. Okay, so now let's just read the description and try to solve the problem. Right? You are given a positive integer days representing the total number of days an employee is available for work starting from day 1. Okay. You are also given a 2D array meetings of size n where meetings I represent starting and the ending day. Okay. Right? Represent the starting and ending days of the meeting. I is inclusive. Okay. Return the count of days when an employee is available for work but no meetings are scheduled, right? So as in this case, you can see the employee is available on like the meetings is scheduled on day 5, 7, 5, like it represents 5, 6, 7. This represents 1, 2, 3. This is 9, 10, right? The available days are 10. Okay, so let me just write how many days he is available, right? He's available on day 1, day 2, day 3. Like the meetings are scheduled on day 1, 2, 3. 4 we can't find out. If 4 doesn't lie in this range. Okay, it is not between 1 and 3. It's not between 5 and 7, and it's not between 9 and 10, right? So it is the meetings are on 5, 6, and 7. Right, then we come to 8. 8 doesn't come in this range, so 9 and 10. So like if we like just find that the employee is available from day 1 to 10, but uh, when are the no meeting schedules, like on the day 4 and the day 8, right? So there are 2 days in which there is no meeting, right? Okay, so we need to return the count. Okay, so the question is pretty straightforward, I guess. Okay. We'll be discussing two approaches to solve it. Okay, I will also be giving the intuition, right? So what's the first thing we can observe? First, there is a range. Okay, okay. So by range, there are two things so that we know. First, we know. Let's just choose a different color. The first thing is our segment tree, right? And for the range type of questions, we have difference array technique, right? Okay. So we will be going with difference array technique, and we won't be going with segment tree. Why? Because like the question isn't very it's pretty straightforward. Okay, so going to segment tree won't be making sense. It we can solve it, but well, let me just show. Okay, I haven't written the constraint, but the array length is like it goes to 10 raised to power 9. Okay, it's like near to this. Okay, so segment tree doesn't make sense. Difference array will also give us MLE. I'm telling you that before, but you should be trying it. Okay, it will be like in your practice to implement this. Okay, it will also give you MLE. But okay, so yeah, right. Okay, but I will be showing you how to do it. Okay, by difference array. Right. Okay. there are like the days are 10. We can make a array of days plus 1. Okay, so it will be having the index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Right? Initially, the values will be 0. Right? Okay. So the first query is 5 comma 7. Okay. So we just add plus 1 at the 5th position and minus 1 at the 8th position, right? Then comes 1 comma 3. So what do? We just add plus 1 to the 1st position and minus 1 to the 4th position. Okay. Then we have the query 9 comma 10. What we just add plus 1 to the 9th position and minus 1 to the 10 plus 1 position, which is like out of bounds. Okay, so we are not gonna add it, right? Now we just find the cumulative sum. Cumulative sum. So which will be 0, 1, 1, 1, 0, 1, 1, 1, 0, 1, and 1. So as you can see, we got our answer, but where it is, like not including the 0 because 0 isn't a day at every place. Like here we have 4, okay, which is our answer, right? And here comes our 8, which is our answer, right? So this is how you can find our, like the index representing the day, okay, like uh, when no meeting is scheduled. Okay, so if we count it, our answer will be count count will be 2, right? So let me just show you the code, and then we will be coming to the actual solution to it. Okay, so here you can see we have taken a difference array in which we have taken days plus 1, then we have taken the descriptor as n, and we have inserted the queries, right? Okay, here is the start, here is the end. Okay, like we have done the plus 1 to the start, and if n plus 1 is less than n, we have subtracted minus 1 to it, right? Then we have calculated the cumulative sum, right? Okay, so at the end we are checking if difference is less than or equal to 0. We are just doing the count plus plus and returning. It will give you the MLU, I guess 500 something. You will get, like you will get the MLU. Okay, so you should be practicing it. Okay. So talking about the time complexity, this solution will take the, like what, we're iterating it once. Okay, like we are iterating it once here, and once here. So it's as good as big O of n, right? And space complexity, we are taking the space, so it should also be n. Okay. So now what we can do? Okay, so now we come to our second approach, right? Okay. So let me just erase it once, then we will be coming to the approach, like the actual one, right? Okay, just okay. So okay, just a second. Okay, so now we come to our second approach. Okay. let's just observe what do we have, right? So we have intervals, like this is an interval. Can we say interval? Yeah, we can say this is an interval like 5 to 7, and this is 1 to 3, and this is 9 to 10. Intervals. And we know like how many days, how many numbers are there. So can we just find out, can we just find out the numbers, okay, from 1 to n, or you can say days, which doesn't lie in these intervals, and that would be our answer. That makes sense, because like if you check for, see, like suppose you check for 1, you can find it in this range, right? Then you check for 2, you can find it, right? Similarly for 3, but for 4 you won't be able to find it, right? Similarly we come to 5 you can find out, right? Similarly for 6 you will find out, right? Because it lies between 5 comma 7, and for 7 you can also find it out, right? But when you come to 8 you won't be able to find out, right? Because 8 is not there, and for 9 you will be, and 10 also you will be able to find out, right? Okay. So see, the intervals, like for, we need to like arrange the intervals in a proper way, right? Like for here, see, there is 1 to 3, and there is 2 to 4. So like we will be checking for like in 1 to 3, and then we'll be checking to 2 to 4. So this will increase the time complexity, right? Okay. So what we can do, we can just merge it. So it will be 1 to 4. Okay, and we can directly check it. So we have solved a question like this, like you might have solved it, which is like merging intervals. So you can just merge them, and then we will be checking it, right? Okay. So let's just suppose I have taken this example 1 comma 3. Okay. So uh, just 1 comma 3. If you like just sort it, it will become something like 1 comma 3. Then we have 5 comma 7, 5 comma 7, and then we have 9 comma 10, 9 comma 10. Okay, and this, there is no overlapping intervals, right? Okay, so we'll check for 1. Does 1 lies in this range? Yeah. Let's just take L as 1, right? 8, yeah, yes, right? Yes. So what do? We don't need to check for 2, or we don't need to check for 3. We can just start from this plus 1, which is 4, right? We can just start from L equals to 4 and check in the other range, right? So does it lie in this range? No. Okay. Then we're checking for 5. Does it lie in this range? Yes. So what do? We just start from this plus 1, which is 8. So does 8 lies in this range? No. Does 9? Yes. So what do? We just start from 10 plus 1, which is 11. But we are like out of bounds, so we need to check it. So it will be something like while I is less than n and while L is like less than, I'll be storing it in a pair. So ARR of ARR of I dot first, right? We do the L plus plus, we do the count plus plus, right? We won't be doing I plus plus because we need to pass this. We need to pass this, right? And at the end, what I will be doing is L will be ARR of I dot second plus 1, and we will be doing I plus plus, and this will give our answer. Okay, so this is probably code for it. Okay. Not the entire code, but like the when we will be calculating it. Merging, I will be show how I'll be showing you how we'll be doing it, right? Okay, so let me just go through the code once, and things will be more clear. We have sorted it in ascending order, right? In ascending order, right? Okay, we will be solving it in ascending order. In a ascending manner, right? I have taken an array of pair for storing the intervals separately. You can like merge it in the same array, right? Okay. So while I is less than n, start and end. Okay. I'm doing the I plus plus, so we are like checking for the next interval, right? If I is less than n and ending is greater than this matrix I, we are just storing E as the maximum of E and the matrix I and increasing the I plus plus, and at last what I am doing is pushing back the starting and the ending time, right? So by this we will be finding out the ARR, and then we are starting from I equals to 0, and we have reinitialized the n as ARR of size, and we are starting the L from 1 and count from 0. So like this is the same code which I have written, right? I is less than n, L is less than ARR of I dot first. Increasing the L, increasing the count, and at last we are doing the L equal to ARR of I dot second plus 1, and we are doing the I plus plus, and at last this. Okay, so what is this? Okay, so let me just tell you this. Okay, like in this case, and 2 comma. Okay, let me just write. Like for the case in which we have 1 comma 3 and 2 comma 4. 1 comma 3 and we have 2 comma 4. So like if you merge it, it will become 1 comma 4, right? So we have like 1 1 2 4 in it. Okay, but the days are 5, right? Okay. So how many days are left? Just in case if it's not it's not under the interval. Days minus ARR dot back dot second, right? Because that's how much days will be left, which is 5 minus 4, which is 1, right? So yeah, that's for handling the edge cases. Okay, and as you can see, the code is running just fine, and we have solved this question, right? Okay, so yeah, that's all for this question. The okay, let's just also discuss the time complexity of it. It's also like it's analog in actually. Why? Because sorting will take n log n, right? And we are equating it, so it's like n. So we are taking the bigger one, so it will be of big n n, right? So this is our time complexity. I am taking the space here, but you can like move it. Okay. So space will be also like something like before, and I would say, right? Okay. So yeah, that's all for the question. The question, like the question link and the code link will be in the description box. Okay, there you can check it out. So yeah, thank you everyone. Have a nice day ahead.